Okay, it says find the end behavior of the polynomial, and the formal way to say that is the limit of f of x as x approaches infinity, and the limit of f of x as x approaches negative infinity. What degree polynomial is this? Third degree polynomial. Now that is an odd degree polynomial. So now if I were to just kind of in my mind, I should be thinking this. Can somebody tell me what a third degree polynomial looks like when you graph it? Okay, you guys are making the motion with your fingers, right? How many possible roots are there? Three possible roots. So it means that it could cross the x-axis how many times? Three. So where does it start?
From the bottom.
Down from the bottom. So it's going to probably go like this. Right? And so we've got we've got 1, 2, 3 possible roots. Now it could go up higher, it could go down lower. We don't really know. I haven't graphed it yet in the calculator. But we want to figure out what the limit of this is as x approaches negative infinity and as x approaches positive infinity. So if I say the limit of f of x as x approaches infinity, what I'm going to look at is I'm going to start somewhere on the graph, and I'm going to look at the behavior of the graph. So as I go in this direction, what does the graph do? The graph goes in this direction, right? It goes this way. So if I keep going this way, what will my y value go? As x approaches positive infinity, what will my y value be? Infinity. So this limit is infinity. Now, what is the limit of f of x as x approaches negative infinity? Same thing. I'm going to look at my graph and I'm going to come around and I'm going to follow it. Okay, as I keep going this way in the x direction, what is this y value going to be? Negative infinity. So what do you think the answer is? C. Now, what we could do, if we wanted to for fun, what I could do is I could come in here and graph it. Whoops, let's turn that off. If I graph it and I say x cubed plus 2x squared plus 5x minus 7. And let me make sure I turn my stat plot off. 4. Alright, now we'll graph it. Oh, I gotta zoom out a little bit. Let's hit the zoom on that bad boy. Uh-oh. Standard. Alright. Alright, so it didn't quite cross the x-axis 3 times because it shifted down a little bit, because we went down 7 units. Alright? But it did start here. So again, if I look at it from this direction, as x approaches negative infinity, my y value approaches negative infinity. And then if I go in this direction, as x approaches positive infinity, y approaches positive infinity. And so that's where all this stuff comes from. Okay? Any questions? Hey, just out of curiosity, since I've got the thing up here, how many real solutions does this have? It has 3 solutions, but how many real solutions does it have? Well, the real solution occurs right here when it crosses the x-axis. So it has 1 real solution. What happened to the other 2? Anybody know? It has to have 3 solutions, so that means there's 2 more solutions. What do we call those other 2 solutions? Complex, yeah. So it has 2 complex. Now, complex solutions are always going to travel in pairs. So if you had the same equation and it was to ask you, how many solutions do you have? And you did some math and you're like, I have one complex solution and 3 real solutions, that would be incorrect. Because why do they travel in pairs? I'll get you started. Conjugates. Complex numbers always travel in conjugates. Okay.